With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. A block of dimension L into T into H and uniform density rho W rests on a rough floor. The wind blows with speed V and the density of the air is rho A. Fall perpendicular on one face of dimension L into H. The block as shown in the figure. Assume that the air is stopped when it strikes the wall. There is sufficient friction on the ground so that the block does not slide. The minimum V so that the block toppled is. So if you see here, it does not slide. It is already said in the question. So if you see the forces on the block. So first of all, normal reaction will act and mg will act like this, let's say. So start with the mg in downward direction, right? And if you see here, the force because of the air, right? Because what happens here, the air strikes and they get to rest, right? If you see, it is given that assume the air stopped. So the change in momentum takes place. If you see the air particle, they suffer the change in momentum in this direction, and the same amount of force the cube will also suffer in this direction. Let's say n dt both are on both of them in opposite direction, right? So what will happen, they will in short we can say this block will experience a thrust force in this direction because of the particle that is striking the block from the left and comes to rest, right? Because the change in momentum is taking place in, if you see visibly, in case of the air particle, and the same force the block will also experience. So this is F thrust, right? And this is not moving in horizontal direction, right? And if you see here, right, if you see here this thrust force, right, this is uniformly acting on this face L into H, right? So this thrust force will be passing through the center of mass, right? So if you see the center O, right, thrust force is passing through the center, mg is passing through the center, but the friction force is not passing, right? And if you see there is no horizontal motion, it is already given in the question. So thrust force is equal to friction force as well, right? So if you see, there is perpendicular distance of the line of action of friction from the center, that is h by 2. If you see, this is h, so this will be h by 2, right? So what is the other torque, from where it is coming, so that it could balance the torque because of the friction force, right? What is the force which is applying the torque in this block so that it could not topple because of the friction that is acting because of this friction. So if you see here, the normal reaction will shift itself like this. It will shift itself from the center, so that the line of action of force of the normal reaction acts at a distance of some distance, so that it could balance the friction force torque. At the critical case, what will happen, it will shift to here. It can't shift more than that, right? If you see, it is directly touching this side. So at the critical case, the normal reaction can shift up to this distance, and this will be, this distance you can see it is t, so this will be t by 2, right? So this will be the situation just before the toppling. If you are going to increase the thrust force more than that, then the toppling will take place, right? So this is the situation. So if you see here, now we are saying that we want it to topple, right? So this thrust force is enough, right? So about this O, the torque will not be 0 anymore since it is about to topple. And if you see the point P also, about P point also, the torque will not be 0. You can take any point, and if you calculate the torque about that point, the torque about that point will not be equals to 0, and at critical case we will take is equals to 0 just before the toppling. And at that critical case, this line of action of this normal reaction will be at a distance of t by 2 from the center, right? So we are calculating the torque because of this p point, about this p point. So I will write down thrust force torque is equals to mg, and if you see this distance, this mg distance, it is t by 2, so I will write down mg t by 2. Normal reaction torque, it will be 0 because it is passing through point P. Friction torque, it is again 0. You can also balance this torque about O also. For that you have to take the friction torque and the normal reaction torque, because in that case the thrust force and the mg will be passing through the center. Since the magnitude of this mg and the thrust force is same, so you will get the same equation, right? You will get the same equation. I will write that also. If you see this, right? Now just if you replace this ft by f, and we know that this mg is equals to the normal reaction. So if you replace this mg by normal reaction, so you can see this will be just the equation about O, right? So both will be same eventually, because we know that the horizontal and vertical forces, the two forces are having equal and opposite magnitude, right? They are equal in magnitude and opposite in direction, I meant, right? So now we got this equation. So what we want the velocity. To calculate the velocity, I will write down the thrust force, that is dm by dt into the v. V relative, if you see, just after striking, it comes to rest, right? So this will be the thrust force. Now I will write down the rate with which the mass strikes is, and we know already the rate of volume change. If I write down, it will be, if you see, L into H, right? If you see, this length is, area is L into H, and the velocity is this. So area into volume I will write down. Area into velocity, right? So this is L into H. So write it down. Now just put it in that equation. So I will put the value in this equation, ft h by 2 mg t by 2, 2 will get cancelled out. So I will write down ft into h. So ft we already calculated, into h, so it will be h square is equals to, it is mgt. T is also there. We want the v, so I will write down mgt by rho L h square. So you can take the under root. So this h square will be outside as h, and this will be the answer. So if you see, the answer is in terms of rho, right? So if you see, we know that the volume of this whole block is, you can calculate in terms of rho w, right? And this is rho air. This is rho air, right? So I will write down the mass is equals to L into H into T, that is volume, into rho W, right? Put it in this equation, and this is rho air. L H T LHT into GT, so it will be T square rho A So we will take this h inside with square, and this will be the expression final, right? If we write down the mass as this, now this h will get cancelled out, L will get cancelled out. Now I can write down it will be rho W G by rho A into H. T you can take outside. This will be the final expression. Now you can check for the option. Rho Wg by rho A into H to the power this. So rho Wg by rho A into H. So A is the correct one. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.